Hello class, and welcome to section 9.9 day 2, which is about exponential functions. By the end of today's lesson, you will be able to graph and apply exponential functions as well as identify the different types of linear and nonlinear functions. The last nonlinear function we're looking at is the exponential function. This is a function that can be written in the form y equals ab to the x power plus c, where b is not equal to 0 and b is also not equal to 1. So, for example, this graph over here that we have illustrates the function y equals 2 to the x power. So this is the most basic function that we have. You could see functions like y is equal to 3 times 2 to the x power, or you could have that addition or subtraction piece there. But we're really just going to focus on these basic ones. So our purposes are not going to have anything outside of this parentheses. It's just going to be a number raised to the exponent for the most part. There will be a few written in this format, but most of them are just going to have this value. But note that if something is in parentheses in the equation, that's how you would have to solve it. But going through, looking at this one that we do have right here, this y equals 2 to the x power, how we got those points to graph would be saying 2 to the negative 2 power, which means 1 over 2 to the second power, which is 1/4. Now, you can go through and write this as a fraction. My strong recommendation is just to type 2 to the negative second power in parentheses and get that answer of 0.25 as a decimal. Then the next point is 2 to the negative first power, which is going to give you 0.5 as a decimal. Then you've got 2 to the 0, which is going to give you 1. So that takes those first 3 points there. And then we've got 2 to the first, which is 2, 2 to the second, which is 4. And then I even included this next couple of points. 2 to the third is 8, 2 to the fourth is 16. So that's how we get those data points to graph. So for example, on this one, we've got y equals 3 to the x power minus 4. So we want to set up and we want to make that xy table. Again, using our 5 basic x values, we are going to plug in -2, -1, 0, 1, and 2. So for that first value into your calculator, you would plug 3 to the negative second power and then minus 4. And that is going to give us an answer of -3.88888, etc. So I'm just going to round that to 3.8 repeating. Then you would do the same thing with 3 to the negative first power minus 4, which is going to give you an answer of -3.6 repeating. Then you would plug in 3 to the 0 power minus 4, which is going to give you -3. And you're going to continue going on with that pattern. And the last two values you are going to get are going to be -1 and +5. Looking at the points I have here, I do not need to renumber my graph. So I'm going to go ahead and say we've got at -2, we've got -1, 2, 3.8. So that's going to be right down there. Then we've got -1, -1, 2, 3.6, right about in the middle. Then we've got 0, -3, 1, -1, and 2, +5. Now you'll notice from this first example that I went over that it has this flat line tail and then it has the curve up part. So when you are graphing this, what I want to see is that when you are drawing that flat line part, if you kept going, you would be getting closer and closer and closer to that -4, but you're never actually going to hit -4. So when you are drawing this flat line part, you want to stay just right above that -4, and then you're going to go ahead and curve up as you go through the rest of those points. So exponential graphs are always going to have this flat line part. In this one, it's on the left side. You might have some that flat line on the right and then go up. But the point is that there's always going to be this flat baseline part. And then once we hit our initial points, it's going to start spiking up. So all of the graphs should look like this, either approaching from the right and spiking up or approaching from the left and then spiking up. Go ahead and try this one on your own. So we get those different values, we plug it into our graph. In this case, again, we got that flat line on the left side part and then spiking up after that. Looking at a word problem to apply exponential functions here, we have a table tennis tournament, has 64 players. Half of the players are eliminated after each round. The function y equals 64, and then in parentheses, 0.5 to the x power, represents the total number of players remaining after each round, where x is the number of rounds. So we're going to make a graph, find the y-intercept, explain its meaning, and then determine how many rounds until there is a champion. So step one, we're going to make the graph. So again, we want to start, in this case, it's a word problem, and x stands for the number of rounds. So we're going to go ahead and use our word problem values, which are 0, 1, 2, 3, and 4. When you plug that in, we're going to say into the calculator, you would plug this in as 64, parenthesis, 0.5, and then parenthesis with the caret, and then you would start by plugging in 0. That's going to give you an answer of 64. Then you would do that same process, but instead of caret 0, you're going to change that to caret 1, and that's going to give you 32. You would continue to plug that same equation in, changing the exponent every time. 2 is going to give you 16, 8 for 3, and 4 for 4. So now we're going to go ahead and jump to making a graph. So we started with 0, 64, which means that we're going to need to fit 64 onto my graph. I'm going to go ahead and just count by tens. So 10, 20, 30, 40, 50, 60, 70, oops, not 64, 60, 70, 80, 90, and 100. Our first point was at 0, 64. So we're going to go 0 and then up 64, which is about halfway between 60 and 70. And then we had 132, so that's going to be down here. Oops, probably a little higher. 132, 216, probably right in the middle-ish again. 3, 8, and then 4, 4. So when you make this graph, you'll notice that this is one of our ones that's going to be flatlining from the right. So we got that flat line coming from the right and then spiking up with the rest of our values. So that's making our graph. The next thing it asked was that we find the y-intercept and explain its meaning. So looking at the graph, I want you to identify the y-intercept and explain what you think it means. So looking at our graph, our y-intercept is 0, 64. That's where it crosses the y-axis. And what this means is that before any of the rounds are played, so when the tournament starts, there are 64 players. So you should have said something along the lines of the tournament started with 64 players. The last thing it asks us to do is figure out after how many rounds there will be a champion. We're going to have to do a little logical processing here. What it means to be a champion is it means that there's only one player left in the tournament. So go ahead and continue that. Go ahead and continue using an extended table to figure out after how many rounds there will only be one player left. So when you extend that table, for 5 you get 2, for 6 you get 1. So what that means is that there will be a champion after 6 rounds. The last thing we're going to look at is just a quick summary of the second half, looking at our linear and non-linear functions. So these are the 4 different types of graphs that we have been looking at. Obviously, this first one is the linear portion, and these next 3 are the non-linear portion, based on it being a straight line or it being curved. Then the specific types we had, linear is just called a linear function. The 3 types of nonlinears we looked at were quadratic with that parabola, that U shape, the cubic, which had the part that went up and the part that went down, and then what we looked at today, which was our exponential function with that flat line tail and then the curve going up. And then, so the pictures are right here, and then the last thing I wanted to touch on was the equations. So your linear equations are going to be in the form y equals mx plus b. Your quadratic equations are y equals ax squared plus bx plus c, so having that exponent of 2. Your cubic being ax to the third plus bx squared plus cx plus d, making sure they have that x to the third power. And then your exponential being y equals a times b to the x power plus c, making sure that exponent is the x. So we want to be able to identify these different functions. Looking at this equation, you would identify the function going to this exponent. We have an exponent of 3, so this would be a cubic function. Go ahead and identify this one based off the graph on your own. And here we have an exponential function with that flat line curve and then curved going up. If you have questions about this or anything else from the lesson, please let me know when you get to class.